Hi guys, hope we all are doing good. So in the previous video we have learned how to traverse a double linked list in both directions, forward and backward directions. So in this today's lecture we will learn another important operation, that is insertion at beginning in linked list. So don't worry, I will explain everything easy. So this the same topic is there in single linked list also, but in double linked list it almost familiar. Let me explain in step by step. So without any delay, let's begin our today's lecture. So suppose we have double linked list. So first double linked list start with null value. So in the example we take 10 in forward and backward, 20 both forward and backward, 30 forward, null value. So this is a double linked list initially. Now we want to insert a new node containing 5. So our new node is 5. So new node is 5. So we want to insert the new node at the beginning of the double linked list. So after inserting the new node, the linked list should be, sorry, the linked list becomes, so let me write. So it gonna becomes null backward 5 forward backward 10 forward backward 20 forward backward 30 forward null. So this is our double linked list after inserting a new node at the beginning. So how can we do it actually? So let us understand step by step. So first, let me draw it in diagrammatic. So this is our 5. So this box contains next address node. So this box contains previous address node. So initially our linked list is null. So this is a box. So three boxes. Let me draw. So these are three boxes. So here it is 10, it is 20, it is 30. So these are the addresses in these two boxes. So let me draw it somewhat bigger so that you can understand. So let me draw it bigger. So this is somewhat okay. This big is okay. So here 20, here 30. So this is the two addresses. So let me draw. So this is our null value. So this was connected to this. Okay, this is 10. So this is connected to this, and this was connected to this, and this is connected to null. So this is a double linked list initially. So it looks like a train, right? So the train has three coaches. So this is 10, 20, 30. So now a new coach number 5 comes. So this is the new coach. It should be become the first coach. So for that we need to disconnect this node. So disconnect this null node. So we are disconnected this node, and what we are doing, and we are connecting to this node. So it becomes this, and we are connecting like this. So this becomes the head. So initially 10 is the head, now 5 will become head. So now the linked list becomes 5 backward forward 10 forward backward 20 forward backward 30 null. So this is our double linked list. So we can connect the new coach with the old first coach. So then we make it the new friend so of the train. So this is our train actually. So initially it has 10, 20, 30. So we added just new coach in front of this 10. So now the head coach becomes 5. So this is how a double linked list work. So let us see the steps. So the step one is we need to create a node, all you know. So first we need to create a node. So let me write. So first we need to write struct node. So this is our node, struct node. We need to create a head. I mean, we need to create a node. That means we need to create new node. Yes, new node. So in this new node, we need to allocate dynamic memory. So new node. So we need to allocate dynamic memory using malloc function. So this is, we have allocated the dynamic memory to our new node. So let me write it again. So malloc, so spelling is wrong, so let me write. So malloc, so we are allocated dynamic memory allocation to the new node. So now memory is allocated successfully. On the second step, we need to store data. New node, new node equal to data equal to 5. So this is our new node data actually. So on the third step, the new data, I mean the new node has no previous node. So initially, if you are adding any element at the beginning of the double linked list, it's automatically become the head node. Obviously, the previous node, I mean the beginning element, it become head. So before head, there will be no element. So the previous will be null. So that's why we need to write new node, new node, yes, new node previous equal to null. Yes, previous new node previous equal to null. So this is the step 3. Now the step 4, we need to connect the new node to the current first node. For that we need to write new node, new node next equal to head. So initially head equal to 10, right? So now new node next will become head. So that means, let me show in this diagram. So this new node next becomes head. So initially this is the head, right? So new node next equal to head. So we are completed it with the step 4. In the step 5, the old first node must point backward to the new node. So that's why we need to write new node, sorry, not new node, head node. So head previous. So head previous becomes what? Head previous becomes, yes, new node. So head previous becomes new node. So now 10 points back to the 5. So now in the step 6, move to the head point. So now the new node becomes head, right? So head equal to, yes, head equal to new node. So this is all about the double link insertion at beginning of a double linked list. Now the head points to the 5. So the final double linked list is, so same, null, 5, forward backward, 10, forward backward, 20, forward backward, 30, and forward null. So this is the, I mean, this is the final double linked list after inserting and, I mean, inserting a new node at the beginning of a double linked list. So insertion is successfully completed. So let us see the C code for this operation. So I have already written the C code. You can check it out. So let me explain it line by line. So this is a star. I mean, this is a two header files. This cannot be neglected. So hashtag include stdio.h and hashtag include stdlib.h. So we have created a node with int data and star next and star previous. In the main function, we have created 4 nodes: head, second, third, new node. This is for the first node initially, for second node and the third node, and this is the new node. So we have allocated dynamic memory allocations for these 3 nodes. So we have given some values. So head equal initially 10, second is initially 20, third is 30. So here for new node, so we have for new node we have allocated dynamic memory also. So same. So now new node data becomes 5, new node previous is null, new node next is head. So head previous equal to new node, head equal to new node. So this is what we seen. So let this, remember these 3 important lines. The first one is, this is the first important, let me write here. So new node next equal to head. So this is the important first line. Head previous is equal to new node, head equal to new node. So these are the 3 important lines in this code. So you need to remember it when this operation for. So insertion at beginning of a double linked list, these 3 operations, I mean these 3 lines are very important. So these are frequently asked in many interviews actually. So we have allocated, I mean we have successfully insert the 5 in the beginning of the double linked list. So now we need to print all elements in the linked list. So for that we have created struct node start temp is equal to initially head. So head starts from the 5. So this is the while loop we are using since when the linked list topic has started. While temp is not equal to null, printf temp data temp equal to temp of next. So we are going to return the 0. So this is what the C code. So the output will be 5, 10, 20, and 30. So this is all about the insertion at beginning of a double linked list. So let us, I have already discussed it way how to in a diagrammatic way. So let me tell again. So initially, first this is a initial node. We have this 5 node. First we are disconnecting this head and the previous node. So we are inserting this 5 at the beginning. So now the connections will be changed, right? So this 5 points to the 10, this 5 previous points to the null, this 10 previous points to the 5, and this is the what insertion at the beginning of a double linked list completed. So this is all about the insertion at the beginning of a double linked list. So let me ask some questions. Why is the new node previous pointer null? So because it becomes the first node, right, and there is no node before it, so in a head node it will be the first node, right, there will be no more nodes before the head node. That's why the head previous equal to null. So head means here new node previous equal to null, that's the reason. So which pointer of the world first node is updated? So obviously the previous pointer of the world node should be updated first. So that's the second question. Let me ask. So this is the important question. Can you guess the question? Yes. What's the time complexity for this operation? So can you guess it? Yes, the time complexity is big of one. So why big of one? So can you see this? The insertion at the beginning is easy, so it won't take that much time. So obviously the time complexity for this operation it becomes is time complexity is big of 1. So this is the time complexity because we are not traversing entire linked list, we are just updating the head value, that's it, we are not traversing, so the time complexity is big of 1. So this is all about the double linked list, insertion at beginning of a double linked list. I hope this lecture is clear to everyone. If you have any doubts you can ask in the comment section. So in the next video we'll learn insertion at the end in a double linked list with a complete C program. So thanks for watching. Don't forget to like the videos and share with your friends, and don't forget to subscribe to our channel. So thank you guys and see you guys in the next lecture.